Hello there. Today, I'm introducing a part of a project that's only ever destined to be a part. This is the PrintShift large bed conveyor. Status is currently beta. I wanted to capture the goals of the project and get it out there as soon as possible. This here is the first assembly. I'm going to talk about what it's doing, why, and where I hope for it to go. First off, what is this? The PrintShift large bed conveyor is a heated conveyor belt suitable for large format printers. I'm generally defining large format printers as 300mm or 12 inches and larger. The idea is that you can replace your current print bed with this conveyor and upgrade your printer to automatic part ejection. Why would you do that? Well, if you look over in this corner, I think, stick it over there. I've got a time-lapse for my Prusa Mini PrintShift implementation. It's chugging away over 24 hours just printing while I design parts and add them to the queue. You might recognize some of the parts. The time-lapse is actually still ongoing. I grabbed this while it was running, because once it ejects the part, you can just, pick it up. To improve on and simplify that Prusa Mini design, this PrintShift model will not be optimizing for moving weight. I.e., it's not going to be suitable for Prusa i3 style printers like the Mini, or anywhere where the bed is moving rapidly, because this is going to be quite heavy. Let's see, most of the parts right here in frame. Anyways, what are we optimizing for? Scalability and adaptability first. One of the goals is that these parts should be common, easy to obtain. There'll be a few substitutions. These are English screws because it's just... I can't not do this. I find it hilarious that 5/16, whereas this is a 5/8 eye hole and a 16mm outside diameter bearing. As you can see, the frame is all 2020 aluminum extrusion. If you look real close, you notice that some of my extrusion is 2020 and some of it is V-rail. You don't need any V-rail, just plain 2020 will work. V-rail is just fine in a pinch. This is built from the remains of many other printers that I've built over the years. You can kind of see my fairly large pile of extra stock lives right down here too. The rollers are 3D printed. I'm pretty tickled by my keyed shaft. When I started with the belt printer, this is the first roller I was working on. It's not terrible, but it's unwieldy. It's difficult to grip. You need a central axle as well as the roller material, and I actually had to drill holes in the ends to keep the drive gears from slipping on the roller. I tried with smaller rollers. The only real problem with the half-inch steel bar is that it's quite expensive, and it's unfortunately necessary so that it won't bend under load. Instead of all that, 2020 aluminum extrusion profile. It's keyed onto it. Pretty tickled. I want to see how well this works. It's cheap. It's available, strong. For this model, I'm experimenting with the trapezoidal rollers. Trapezoid? The idea being that the belt will actually track towards the center, and we don't have to do any severe guiding. We'll see how that goes, and if it's a bad idea, well, it's a print to swap them into just straight rollers. You could also make a belt that has a textured underside. Maybe a belt that looks more like a timing belt. Could actually track the pulley. Next thing we're optimizing is strength, while we have all these guys going. I'm going to start assembling. I did tap the ends of the extrusion before I started the recording. Sorry, but tapping isn't the most exciting thing in the world, so I feel like you probably don't need to watch me do it. Easiest way to press fit. Feel like you probably shouldn't do that. We'll make a metric or version of this that's pure metric. The next thing we're optimizing for is strength. It's pretty hard to beat the aluminum box frame, and this design accommodates stretchers and springs for putting high tension on the belt. The belt drive uses step-up pulleys and timing belts. Here I've got a 16 to 60 advantage on the stepper motors. These steppers are important for flexibility, so that you can drive the belt precisely straight from your printer's electronics. With the GT2 timing belt, we also have very low backlash, so you can even use the belt as a Y-axis if you're so inclined. Build an XZ stage in the middle of this platform, and boom, it's a whole printer. The center rails are clear, so you can mount whatever bed you'd like. 3D print some side mounts, or if you even need, you can run the belts horizontally. I'd rather not do that because I want the belt to be fully removable. I usually hold down the bed by gravity, and then the belt going over the top clamps it into place. That way, swapping the belt is easy. You detension it, pop the rollers off, and pop a new belt on. The lower frame rails can be extended arbitrarily, maybe as long as you want, and use them to connect the bed to your printer. I'm basically thinking of how the Voron is built here. For my install, I'll be cutting them short, just to fit, and adding some guides and lugs to the side so they can fit inside my old Doppelbot here. Speaking of which, most of the Doppelbot upgrades are in the can, only working on the extruding and commissioning, and of course this bed. Next step, I'll show you this model fully functional, but the test build has gone well. I'd love feedback on whether or not you think it's good or suitable for whatever kind of printer you're thinking about automating. To that end, all the STL files are available on GitHub. I'll be making text instructions over at PrintShift.com. Ideally, I'd like to organize it for different size printers, rollers, and different bed mounting styles. One thing you should note, the lengths of these beams do not make any difference. The corners will handle as long as you want. More soon. Thanks for watching, and happy printing.